Boom. You're going to flip forward in your notes. We're not ready to do the first lesson because you would not be ready to necessarily work on that right away. So flip forward till you see this page. Should be about the fourth page. You all good? You guys see it?
Yep.
Nope. Flip again. There you go. Okay. So we want to move to something that we could call a derivative. There's three big ideas in calculus. One is limits, one is derivatives, and one is integrals. Those are the three big things. We're ready to pretty much set limits aside. We'll touch them again about 3-4 times during this class. Not much, just a little bit. But we need to talk about derivatives. Okay. So definition 1 for slope of a tangent line. We wrote as follows. Remember we used this picture on your last test? We called that point A. What do we call this spot? F of A. We said you can't find the slope at one point, so therefore you make a second point. We'll call that X. So what's this? F of X. And so we had F of X minus F of A over X minus A. That was the slope of the secant line. What do we do to make the slope of the secant line become more like the slope of the tangent line? Move X to A. How do we move X to A? Slap a limit on it. Limit as X goes to A. You good with that? Old hat, right? Technically, that's a derivative. We don't like that one as much. The reason why we don't like it is because it requires an initial point A before we even really begin. What we would like to do in this situation is we'd like to use this definition, definition number 2. I have a function, I have a point, we're going to call that X. Therefore, this is F of X. We would like to find the slope of the line tangent. Difficult to do because there is just one point. So therefore we create a second point. And what we're going to do is we're going to move over a certain number of units. We're going to call this one X plus H. So this is F of X plus H. Everybody see that? Mm-hmm. All right. Now, I worked very hard over the years to try to set you up for this moment. Let's see if it works out. Y sub 2. Minus Y sub 1. Over X sub 2. Minus X sub 1. What do you notice?
The x's cancel out in the bottom.
So therefore, I get F of X plus H minus F of X all over H. Does that look familiar?
The thing from last year.
The thing from last year. Yep. The thing last year was instead of an X, it was an A. F of A plus H minus F of A over H. We did in chapter 2. We're like, hey, if it doesn't have an H, it should cancel, and like an H divided off. We've practiced this before. So you're going to have success doing it right now. My son, last night, was sitting down on the couch. He's like, Dad, can you help me with my calculus? And he was going through this stuff, and I realized his teacher, it was the first time he had seen it. You've seen it before in pre-calc, you know what I mean? So I've seen that skill. That's the advantage of having a pre-calculus teacher who then teaches you calculus. You see the connectivity. So, but here's what I want you to see right now before we practice it, okay, is right now that's the slope of the secant line. How do I come up with the slope of the tangent line? What do I do? What's that distance?
H.
What do you want the distance between those to become?
It's closer. Smaller.
So you want that distance, or h, to go to 0. And so I'm teaching this a little bit out of order and context to your book, but we're showing you definition 2. If we were to put in an a there, it would be at a point, kind of like we have a here, but we're using x because we're actually create the derivative of a function. And one thing that we learned in the lesson previous to this is that what we would like to do is we'd like to find the derivative of the function, and that's how we mark derivative. We put that apostrophe up there. And what derivative means is the slope of a line tangent at a point on the curve. And we use the limit as h goes to 0 of f of x plus h minus f of x over h. Okay? That is the formula for a derivative. So if you see this symbol, that means you add two things together. You know what to do. If you see this symbol, you divide them. If you see this symbol, you're like, oh, that's composition, where I put a function inside of a function, right? You're used to these operations. This is a new operation you're learning. So operation of a limit, we talked about that. Operation of a derivative, that's what we're talking about now. That means that you do that. So I would like to find the derivative at a given point. So what I'm going to do is I'm going to write the limit as h goes to 0. And instead of x, I plug in x plus h. So I have negative 4 times x plus h plus 5. So does everybody see that that is the f of x plus h portion? Then I subtract what?
Negative 4.
Negative 4x plus 5, right?
Yeah.
So I subtract negative 4x plus 5. Make sure you distribute that subtraction sign all the way through. And I divide it by h. So I have the limit as h goes to 0 of a negative 4x minus 4h plus 5. Then what? Plus 4x minus 5 all over h. What do you notice? Everything that doesn't have an h cancels. And that should happen every time. The negative 4x and the positive 4x are gone. The positive 5 and the negative 5 are gone. And negative 4h divided by h is?
Negative 4.
Negative 4. Now, let's think about what we're being asked to do. We're asked to find the slope of the tangent line at any given point. Well, what kind of a shape does this make if you graph it? A line. And what's the slope of the line? Yeah. We actually knew it right from the beginning, right? Yeah. But this makes a parabola. And we don't know exactly what the slope is at a certain point. Sometimes it's 0, sometimes it's negative, sometimes it's positive. So let's try this here. Limit as h goes to 0 of x plus h quantity squared plus 14 times x plus h plus 6 minus the quantity x squared plus 14x plus 6. and it all just sits over h.
Where's the -3 fit into that?
We'll do that in just a second. So we have the limit as h goes to 0 of, what is x plus h quantity squared?
X squared plus 2h.
Good. So I multiplied that out. I have a 14x. I have a 14h plus 6 minus x squared minus 14x minus 6. We're okay with that? Limit as h goes to 0 of, let's see what happens. X squared's gone. 14x, gone. 6, gone. Does everything else have an h? What do we get if we divide the h out? Instead of 2xh, we just have 2x
Plus h.
plus h plus 14. So notice it says the limit as h goes to 0. So now we plug in 0. We have to let h go to 0. Your final answer should not have an h in the problem. And what we get is the derivative. The derivative function is 2x plus 14. So as you look at x squared plus 14x plus 6, that's a parabola. It turns out that its derivative is 2x plus 14. So if we want to find the slope at -3, all we do is have to plug -3 in there. And so f prime of -3 is equal to 8. So what's great about the derivative as a function is all you have to do is find the rule for the function, and then you can plug in whatever point you want, and it'll produce the slope at any spot. So you don't have to do the equation over and over and over and over again. You maybe heard me say prime. The word prime is short for taking the derivative. So we read that as f prime of -3, or f prime of x. Okay. Try letter C on your own. Try letter C.
I didn't get that hard.
I wonder if the soft and chewy chocolate chip cookies kind of help the test scores compared to the Oreos.
Probably, must be.
Let's test this out.
Go all in for this one, and I can make you guys chocolate chip cookie bars. My chocolate chip cookie bars are legendary. I want break.
I don't believe it. I don't believe it. You're gonna have to prove it. Just don't believe it till I.
Tasted it.
Yeah. I'm good.
But the shots are right.
Did you get it?
Yeah.
I thought
Pick out your calculator.
did something. I'll give it.
Yeah?
I think you're right.
You guys, this unit is gonna be very algebraic intensive. Okay? So, does everybody agree that what we're talking about here with the derivative, again, we're talking about the slope of a tangent line? Brody, how would you describe slope?
Rise over run.
Rise over run. Does rise have to do with your x values or your y values?
Why?
So you would be saying like the change in the y over the change in the x?
Yeah.
So change, we would say, is like delta y over delta x, or dy over dx. Go into your calculator, go into y equals, type in that function we did. Is it 3x minus x squared?
3x minus 2x squared.
We got it? Second, calculate. Let's check the derivative at x is equal to 3. Anybody want to guess which one I choose? Number 6, dy over dx. I type in 3, I press enter, and it says that dy over dx, or the derivative, is negative 9. Forget about that. What if I told you guys that when I first looked at the problem, it took me 1.5 seconds before I found out that the slope was negative 9. I didn't even have to do all that.
How do you know?
I'll teach you. Not today, but I'll teach you. You'll know too. All right, what's different about letter D? What's different about letter D?
Fraction.
Fraction, okay? We'll see how many of these examples we can get through. I have a total of 8. I don't know if we're gonna get through all 8. We've done 3 so far. Let's try this one right here.
Jens, what do I click once I'm in y squared?
So then you go second calculate, and you grab number 6. You're gonna come, whoop, you're gonna pause your part there. I'm gonna do that, x equals 3. Limit as h goes to 0 of 4 over x plus h plus 1 minus 4 over x plus 1 all over h. What to do, what to do, what to do?
Probably get a common denominator.
Probably.
No.
Limit as h goes to 0. So I'm going to multiply the top and bottom here by x plus 1. So what's that going to give me on the top?
4x plus 4.
4x plus 4. It's so nice that you guys like see the structure of complex fractions, because some other classes I have to write all this out over and over again. And then when I multiply top and bottom here by
X plus h plus 1.
x plus h plus 1. And we distribute the negative 4, where you get a minus 4x, minus 4h, minus 4. Over, what's the new denominator?
X plus h plus 1.
X plus h plus 1, good.
Times x plus 1.
And let's leave that like that, let's not multiply at all. Over
H.
h over 1. So this was my son last night, and he got yelled at this moment. Okay? He did not write the h over 1. He's like, I'll just deal with that later. And then he didn't write the limit as h goes to 0 either. And then his final answer, he got something like h plus 1 over negative h, and he did that. And then I yelled at him again. And I said, your work is lazy, you're sloppy, you need to do better for calculus. It demands more. Write your limit statement, write your h over 1.
Go to your room.
Oh my gosh. Hey, he thinks he's this smart. He's this smart. He ain't this smart. He needs to respect the subject matter more than he does. So we're trying to teach that. Okay? All right, what do you notice?
You can multiply. So, yeah, the top.
Cancel. Hayden, you said something about multiply?
Yeah.
Multiply by what?
Reciprocal.
The reciprocal. So I could take this h over 1 and I could multiply by 1 over h, which again is what Micah failed to do. And I get the limit as h goes to 0 of, what's going to be in the numerator now?
Probably 0.
Negative 4h over.
So notice what I have in the top is negative 4h. Does everybody see that that h is going to reduce with that one?
Yeah.
Every single time, the h in the denominator has to divide out. Every single time. If it doesn't, something went wrong. So this h is dividing out. So I have a negative 4 on the top, and the bottom, I have x plus h plus 1, and I have x plus 1. Notice I still wrote my limit statement because I still need to plug in what?
0.
0 for h. And when I plug in 0 for h, I get x plus 1 times, which is
X squared plus 2x.
x plus 1 quantity squared. Yeah, you could write it as x squared plus 2x plus 1. I give you credit for that, but we just write it like that. That's the derivative. I want to know the derivative for a value of negative 2. So what is f prime of negative 2? What is the derivative value at negative 2? Well, that's easy. Negative 2 plus 1 is negative 1. Squared is 1. I get negative 4. If you want to check your answer, you can simply plug in your calculator. All right.
Can you explain one more time how you got x plus 1 squared?
Yeah, so I
there's an h there.
plug in a 0 for the h,
Oh.
and I get x plus 1 times x plus 1. You like that?
Yeah, that makes more sense.
Flip it over. We for sure got to get through 2. If we don't get through 3, that's going to be okay. Again, you have all day tomorrow to work on the assignment. I need to point out which assignment it is. What's different about this one?
Square root.
All right, fortunately you know what to do because we've been practicing. When his h goes to 0 of, what do I plug in for x?
X plus h.
X plus h. X plus h minus 3 minus the root of x minus 3 all over h. What to do, what to do, what to do. Yes.
You multiply by the
Conjugate.
I always say the reciprocal, but it's conjugate, isn't
It is conjugate. Good. Yep. Good job. Okay. This looks really, really messy. Show it the patience that it needs, and we'll deal with the denominator in a second here. I have the limit as h goes to 0 of, what's going to be in the top now?
X plus h minus 3.
Minus what?
Minus 3.
Minus x minus 3. Over, everybody agree the denominator is kind of ugly?
Yeah.
Okay, we have an h times a quantity of square root of x plus h minus 3 plus square root of x minus 3. That's what we're going to have to pay very close attention to here, because it's going to work out very nicely, but what reduces in the top?
X's.
The x's are gone,
Sorry, 3.
so are the 3's, just like we anticipated, negative 3, and that's going to be a positive 3. And then I have an h in the top and the h in the bottom. Divides to give me 1 over that thing. So I have the limit as h goes to 0 of 1 over. Now I have the square root of x plus h minus 3 plus the square root of x minus 3. So the calculus is telling me the last thing I need to do is plug in 0. And you get the square root of x minus 3 plus the square root of x minus 3. Tell the person next to you, what is the square root of x minus 3 plus the square root of x minus 3? It's 2 roots of x minus 3. Right? It's 2 of them. And in this case, I'm asked to find the derivative at x is equal to 12. So f prime of 12 is equal to, so the derivative as a function is 1 over 2 roots of x minus 3. And we'll talk more about what it means for a derivative to be a function, so on and so forth. But I plug in 12. 12 minus 3 is 9. Square root is 3 times 2 is 6. I get 1/6. This is the same type of process that we did before, just a slightly different rule. Hi.
So if you type that in our calculator, it'll say 1/6.
It will. If you type in the square, it'll say 0.1666. Yeah. Could you warn me?
I think you should type it in your calculator.
I think we should make sure.
You warn me.
We should check. We need to make sure.
Chance, just type it into the
Obvious,
calculator.
we use
just
it
wanna
every
check.
time.
No, I'm not catching on because I think I'm teaching high school, not kindergarten. Okay, so if you could like do that or something, like give me a hint. Yeah, do that, and I'll change the problem. Instead of 12, I'll make it a 52. I can do it quickly. That way, 52 minus 3 is 49. Shoot, square 497.
Dang
Yeah. Screwed up again. So, all right.
You better check it.
Okay, we are not going to get, I don't think we're going to get through G and H, but we will get through here. So let's set this up. This is an important aspect to help you out.
You just
Bro.
It's all I know.
Peter's coming for you.
Oh boy, oh boy, oh boy, oh boy. Look at that. There are so many connections with calculus, and I can't even point them all out. We just don't have time. But since we have an extra moment in here, because we're not going to do the other 2 props, can I show you something that I think is cool?
Sure. Show us something.
Okay, so if you consider the graph like this, and suppose we were to shift that graph up a few units, do you guys agree that even though we shift it up or down, that the slope is still the same wherever we're at?
Mm-hmm.
It still has the same rate of change, right? And isn't it the constant on the end that always determines where it's located up or down?
Yep.
Well, look what happens with the constants every time. They just subtract right on off. You notice that? So it's true that when you see these, you actually could just ignore the +1. You don't even need it. You know what I mean? It's just going to disappear every single time, isn't it? Every single time. Because it does not matter in terms of determining the slope. Now, would everybody agree that right now you're like kind of worried about the whole x plus h to the 4th power thing?
Yeah.
Okay, yeah. We should be a little bit concerned about that, shouldn't we? But fortunately, you remember what?
That division.
Yeah. Christmas tree. Yeah. No, that's not that cute.
Remember Pascal's triangle, right?
No.
Oh, of course.
What's the next row? 1,
1, 5, 6,
7.
10, 10, 5, 1. Remember, you add the ones before, so 1, 6, 15, 20, 15, 6, 1, right? So, one more time.
One more time.
Okay, start with a 1.
7.
1 plus 6 is
7. Is this recording?
6 plus 15 is
21.
21. 15 plus 20 is, and then it continues on down.
No, up till 6.
Okay,
Plus
so we'll go to that. Now, if it's to the 4th power, we want to grab the one whose second number is 4. That's the one it goes with. Okay, all right. I'm going to use this space I'm gonna use the space down here because I'm afraid you guys might not have enough room, okay? So, just gonna hold it there so I can see everything. But we have the limit, as h goes to 0, you guys can write it down here if you want. But so I'm gonna write it out as 2 times, and x plus h to the 4th is gonna be easy. It's gonna be an x to the 4th. It's gonna be an x cubed h. It's gonna be an x squared h squared. It's gonna be an xh cubed. It's gonna be an h to the 4th. And what we need to know are the coefficients. What is the coefficient in front of x cubed h? 4. Because 1 is the coefficient in front of x to the 4th. What's the coefficient in front of x squared h squared? 6. 4 and 1. We've got a minus x. We've got a minus h. We have a plus 1. We have a minus 2x to the 4th. We have a plus x. And we have a minus 1. That all sits over h. And if we've done our work correctly, we know that everything that doesn't have an h should cancel. We'll see if we can keep up with the work here. We'll be ending with this one. But let's just start to get rid of stuff. This negative x reduces with the positive x. The ones, just like we predicted. And then that negative 2x to the 4th is going to go away with this 2x to the 4th right there, right? And so we can write what remains. We will not have a 4x cubed h, but an 8x cubed h. Followed by what?
14x squared h squared.
Good, 16. I'm sorry, 12 x squared h squared. And then an 8 x h cubed. And then what?
2h to the 4th.
Then a 2h to the 4th. And finally, a minus h. All over h. Does everything that's left have an h? So we could divide an h out. We're almost done. Limit as h goes to 0. If I divide the h out, what am I left with?
8x to the 3rd.
8x to the 3rd.
Plus 12x squared h.
No, yeah, h should be right.
Good.
Plus 8x h squared
Good.
plus 2h3.
Good. So we need to let h go to 0. And if h goes to 0, do you agree that that term is just going to disappear?
Yeah.
And this is going to just disappear? And this is going to just disappear? And so it turns out that the derivative f prime of x is equal to 8x cubed minus 1. And that the slope at 1 is 7. Impressive.
So you took an h out.
Yep. I divided h
Every
off
one
from
of
every
them.
single term.
Alright, and then you,
And then I plug 0 in for wherever there was an h due to my limit.
oh, 0.
Time out. Look at your homework quick.
Yeah. Yes, sir.
This one right here, that says the formal definition of the derivative. Okay? This is the one that you want to work on. I know it seems out of order, but this is gonna be the best use of your time that you've seen those, okay? We should be good to go. Have a great day. I think it'll be Mr. Gentle that will be subbing for you guys. So.